Hello, today we're going to be looking at section 9.1, which is all about reflections. I mentioned yesterday that we're going to be looking at transformations throughout chapter 9. And you probably know a transformation is where you take a figure and use it to create a new figure. Your original picture is called the pre-image, and the new figure is called the image. We're going to study 4 transformations in this chapter: translations, reflections, rotations, and dilations. Of those 4 transformations, 3 of them are something called an isometry. An isometry is a transformation where the pre-image before and image after are congruent. An isometry is also referred to as a congruence transformation because it preserves congruence. Of the 4 transformations, 3 of them are isometries, 1 is not. Reflection, rotation, and translations are all isometries, but typically a dilation, where you enlarge or shrink an image, is not an isometry. The focus of today's lesson is going to be on reflections, which are where you flip an object over. You can perform a reflection over a point, a line, or a plane. We're going to perform reflections most typically over a line, which is called the line of reflection, the line that you flip your picture over. But we're also going to look at reflections over a point, most notably the origin. The first picture on your notes shows you an example of a reflection. Here they're taking a polygon, ABCD, E, shown in blue, and reflecting it over the line of reflection, which has the name line M. The image, what we get after the reflection is performed, is shown in green. I know that this is the image because of the markings of the letters. When you look at each of these letters, next to them, they have something that looks sort of like an apostrophe, perhaps to the first power. But this is actually the way that we show where a point ends up once it's reflected. So something like A and that little line is actually called A prime. So when our pre-image is A, B, C, D, E, the image becomes A prime, B prime, C prime, D prime, E prime. The first set of questions on the notes are a little bit tricky to do on a digital lesson. It's much easier to see in person, but I'll do my best to explain one of them. I would like you to see if you can try them on the homework tonight, but if you're not able to, that's okay. You can focus on the questions that are on the coordinate plane. So I would like you to take a look at question number 2. It says, use the figure, draw the reflected image in the given line using a ruler. So you may want to pause the video now and go grab a ruler. Okay, now that you're back with your ruler, the first step in order to reflect in a line not on the coordinate plane is to draw one line perpendicular to the line of reflection through each point. So for point K, I'm going to draw a line through point K perpendicular to line M, like this. Draw another line, do the best you can to eyeball that it's perpendicular to the line of reflection and goes through point L. And finally, a third line perpendicular to the line of reflection and through point J. When a point gets flipped over the line of reflection, the pre-image and the image must be equidistant to the line of reflection. So you would then want to measure the distance from the point that you're going to reflect. So let's start with point K to the line of reflection. So measure along this perpendicular from point K to line M. Let's say that that distance is about 1 inch. Again, I'm not sure what the actual distance is on the digital platform, but let's just call it an inch. To figure out where I would put K prime once the point is flipped over, I would measure that same distance, but on the opposite side of the line of reflection. So now I measure out 1 inch on the other side to find the placement of point K prime. That process gets repeated for each of the points. So now if I measure from point L to the line of reflection, perhaps that's 1/4 of an inch. I recreate that distance, that 1/4 of an inch, on the other side of the line of reflection to find L prime. Point J is the easiest of the 3 points. It is 0 inches away from the line of reflection. It sits on the line of reflection. So when I flip it over, it's still going to be 0 inches away. So J actually does not move. To show that, we typically just mark this with a little slash and the name J prime. Once you reflect each of your points, you should then, of course, connect them. So here's K prime, L prime, and J prime. And typically I like to shade in my image just so that it stands out from the rest. Okay, when you're actually doing this on a piece of paper, you do not need to mark the measurements that you've come up with. So I'm going to get rid of this the best I can, just so you can see what this would actually look like on a piece of paper. Okay, let's focus on the reflections that are performed on the coordinate plane. So take a look now, please, at questions number 3 and 4. Here it says triangle JKL has these specific vertices. Graph the triangle and its image in the given line. So for question number 3, we're going to take triangle JKL and reflect it over the line x equals -4. Remember, x equals a number is always a vertical line, so I've graphed that here. We're actually going to use the same concept as what we did in question number 2 to perform this reflection on the coordinate plane. I can measure from each individual point to the line x equals -4 at a perpendicular, and then reuse that distance on the other side of the line of reflection. So if I start with point J, I can measure 1, 2, 3, 4 spaces from J to the line of reflection. So I count 4 spaces on the other side of the line of reflection to determine the location of J prime. Point K is 2 spaces to the right of the line of reflection, so K prime will be 2 spaces to the left of the line of reflection. Point L is 2 spaces to the left, so L prime will be 2 spaces to the right. Again, typically you wouldn't show what I call these little bunny hops, so let me get rid of them before I draw my image. And now you can see the image J prime, K prime, L prime should look like this. Again, I'm going to shade in the image a little bit so that you can see it. And notice here that this is, in fact, an isometry. The original triangle and its reflection are congruent. For question number 4, we're going to do the same idea. We're still working with triangle JKL, but this time we're reflecting over the line y equals 2. Y equals a number always creates a horizontal line. This time when we measure at a perpendicular, we're measuring vertically. So I'm going to count how far J is above the line of reflection. It's only 1 space above. So J prime will be 1 space below the line of reflection. Point K is 3 spaces below the line of reflection. So K prime will be up here, 3 spaces above the line of reflection. And following that same idea, L prime should end up here. Connect your new points. I'm going to shade the image in again to distinguish it from the pre-image. And the reflection should look like this. On the back side of your notes, we're going to look at a couple of the special cases of reflections on the coordinate plane. So when we flip over just kind of any line, we use that method of measuring the distance from each individual point to the line of reflection. But there are certain shortcuts that we can take depending on what we're reflecting over. The 4 shortcuts at the top of the paper here talk about the reflections over the x-axis, y-axis, origin, and y equals x. Let's look at each of them individually as they correspond to some of the examples. So the first one is a reflection over the x-axis. When you perform a reflection over the x-axis, you're essentially flipping your image from top to bottom or bottom to top. You're moving in an up and down motion. When you do that, the x-coordinate doesn't change, but a y-coordinate does. It changes sign. Positive becomes negative, or negative becomes positive. So you can see the rule up here at the top says that when you flip over the x-axis, your original points change so that the x-coordinate's the same, but the y-coordinate switches sign. For something like question number 5, we're going to reflect line segment AB over the x-axis. So I've drawn the original pre-image. And for this type of question, I like to use the rule to create the coordinates of the image before I graph it. So using this rule, if point A was at 2, 4, A prime is going to go to 2, negative 4. Only the y-coordinate switches signs. If point B was at negative 3, negative 3, B prime is going to go to negative 3, positive 3. Graph your new coordinates. Make sure you label them A prime and B prime. And hopefully you can visualize this is what it would look like if we flip the line segment perfectly over the x-axis. Since you're working on a piece of paper, you can try folding your piece of paper perfectly along the x-axis. If you hold your piece of paper up to the light, folded still, you should be able to see that A and A prime will sit on top of each other. B and B prime will also sit on top of each other. Okay, take a look at question number 6. In question number 6, we're performing a reflection, this time over the y-axis. So that flips our picture left to right. Since we're flipping left to right this time, our x-coordinate is going to change sign, but the y-coordinate stays the same. A reflection in the y-axis, the y-coordinate stays the same. The x-coordinate switches sign. So in question number 6, we're looking at triangle ABC. Again, I'm going to use our rule to first find the coordinates of A prime, B prime, and C prime. So if I take each of these points and I switch only their x-coordinate sign, A prime should go to 1, 4. B prime should be located at negative 4, negative 2. And C prime is actually going to be at the same coordinates as point C. 0 doesn't have a sign, so I can't make it negative. Once I plot my new points, and connect them, we can see the reflection over the y-axis. Again, if you were to fold your piece of paper in the y-axis and hold it up to the light, each of the corresponding points should sit on top of each other. Our next transformation is going to be a reflection about the origin. A reflection over the origin is a combination of both a reflection in the x-axis and the y-axis. If you see the rule up at the top here, the original point AB becomes negative A, negative B. Combination of flipping in both the x and the y-axis. So if you take a look down at question number 7, we're going to reflect triangle DEF over the origin. Again, I would like to use the rule to first find the new coordinates. So if I switch both the x and the y coordinate signs, point D was at -1, -3. So D prime is going to go to +1, +3. E was at 3, -2. When I switch the signs, E prime goes to -3, +2. And F at 1, 1 becomes F prime at -1, -1. Okay, our final rule and the final example are for a reflection over the line y equals x. So first, I would like you to graph the line y equals x. Remember, it has its y-intercept at the origin and a slope of 1. So the line y equals x looks like this. If you think about that equation, y equals x, when we reflect an image over this line, we're going to switch the two coordinates, not their signs, but the actual coordinates. So take a look back up at the rule, up at the top here. For a reflection over y equals x, the original point, AB, becomes BA. The y number now equals the x number, or if I read it backwards, the x number now equals the y number. Switch the two coordinates. So for this last question, let's follow the same process. So point G was at -1, 2. So G prime will go to 2, -1. When I switch the coordinates of H, H prime will end up at 3, 2. I prime should be at 1, 6. And J prime should go to 0, 3. When I graph my image, your final image should look like this. I believe that there's one question in the homework tonight that asks you to perform a reflection over the line y equals -x. Even though that rule is not included on this note sheet, I just want to give you an idea of what that would be. When you reflect over the line y equals -x, your coordinates for each individual point, A, B, not only switch places, but they also switch signs. So AB becomes -B, -A. Remember, the line y equals -x also has a y-intercept at the origin, but since its slope is -1, the graph would look like this. Please make sure that you complete tonight's corresponding homework and upload an image of that to Teams. I will talk to you tomorrow.